All right, thank you for watching this video. We are group number 5, and we will be going over this week's case study, the Pensacola case study. So our group consists of Alicia, Amanda, Gina, Laura, and then me, Lexus. So the first question is, consider the $50,000 excess cash. Assume that Gary invests the funds in a 1-year CD. And when we say CD throughout this PowerPoint, just know that it means certificate of deposit. So A asks, what is the CD's value at maturity? So like, what is the future value if it pays 10% annual interest? And then B, what will its future value be if this CD pays 5% interest? And then if it pays 15% interest. So the solution for 1A, we use the equation from the book that's future value equals present value times 1 plus I, which is interest, and then N, which is the number of times, or like annually, or how many years. And so if we plug in the information that we know, then we get a future value of $55,000. And then if we go down to 1B, we're going to be doing the same equation, but our interest rate has changed according to the problem to 5%. So if it's 5% interest, then we're going to get a future value of $52,500. Or if the annual interest rate changes to 15%, then the future value will be $57,500. Okay, so on number 2, it just has us rework question 1, assuming that the certificate of deposit has a 5-year maturity. So once again, we use that equation, but this time for the N, the number of years in this case, it has a 5-year maturity, so you're going to multiply that by 5 on the end, as you can see. So your future value on 2A is going to be $80,525. And then if we move down to 2B, where it changes the interest rate to 5%, we're just going to do that same equation, but again, adding the 5 for the 5-year maturity. And our future value with the 5-year maturity is going to be $63,815. And then same with the other equation here on the right. You're just going to plug in that 0.15 for the 15% and then add the 5. Well, multiply by the 5 on the end for the 5-year maturity, and that'll give us a total future value of $100,570. And then question C asks, if Bank South offers certificates of deposit with 10% nominal stated interest but compounded semi-annually, what is the effective annual rate on this CD? And then what will the future value be after 1 year if $50,000 was invested? So that's where you're going to use this equation up at the top. That's also in the book. You can refer to it there. We're just dividing by M because it's compounding, let's see, semi-annually. So it's going to be dividing by 2. So we do this equation with the 0.10, so the 10% interest rate, and divide that by 2 since it's being compounded semi-annually. And then you're going to get an annual rate of 1.1025 and a future value of $82,445. And then on 2D, it asks, the Pensacola branch of Bank of America offers a 10% CD with daily compounding. What are the CD's effective annual rate and its value at maturity 1 year from now if $50,000 is invested? And so we assume that it's a 365-day year. So on this equation for the M, you're going to plug in the 365 since there's going to be compounding of that 10% rate daily. And so your future value is $82,430. And then your annual rate is going to be 1.6486. And number 3, now consider the surgery center's goal of having $200,000 available in 5 years to buy a new patient billing system. What lump sum amount must be invested today in a CD paying 10% annual interest to accumulate the needed 200,000? What annual interest rate is needed to produce 200,000 after 5 years if only 100,000 is invested? So for 3A, we're going to use this equation here. For the present value equals future value divided by 1 plus the rate, and then with the superscript of n, which is the number of years or months. So if we plug in the information that we know with our future value, desiring the future value to be 200,000, then we're going to get a present value of $124,184.27. And with 3B, which annual interest rate is needed to produce 200,000 after 5 years? So if our future value is 200,000, it will equal 100,000, which is how much we invested. So that's our present value, times 1 plus, we're leaving the interest percentage blank because that's what we're trying to find. And it's raised to the 5 because there's 5. We want to know after 5 years what the annual interest rate needed will be. So it's 14.87%. Now consider an alternative for accumulating funds to buy the new billing system. In lieu of a lump sum investment, assume that 5 annual payments, $32,000, are made at the end of each year. So 4A, so what type of annuity is this? This would be an ordinary annuity, and it's because it's a payment of fixed payments made toward the end of an accounting period for over an X amount of months or years. And then 4B asks, what is the present value of this annuity if the opportunity cost rate is 10% annually or 10% compounded semi-annually? So if we look at 4B, there's our payment, our rate, and our interest. When we plug that into the present value equation to get to the $121,305.18. You can also do this in Excel, and it shows you how to do that in the book. And then if you go to your right, the 10% compounded semi-annually, so it's going to be the same equation, but this time it's going to be by 10% compounded semi-annually. So we divide that 10% by 2, and it'll give us a present value of $247,095.52. And then 4C asks, what's the future value of this annuity if the payments are invested in an account that pays 10% interest annually or 10% compounded semi-annually? So the same question, but you're just trying to find future value. So we know that our payment's $32,000. We know it's going to be over 5 annual payments, and that our interest is 10%. So if we plug that in, we will get $195,363.20 for our future value. And then if we do semi-annually, meaning instead of just 5 times, it's going to be 10 times compounding, then we will get a future value of $402,492.56. And then 4D and 4E, what annual interest rate is required to accumulate the $200,000 needed to make the purchase, assuming a $32,000 annual payment? And then what size annual payment is needed to accumulate $200,000 under annual compounding at a 10% interest rate? So if you look here, we also did this in Excel. So the future value, payment, and oh my gosh, I forgot the name of that, but how many times per year, then your rate will be 11.8% with the data given. And then 4E, future value is 200,000 in N years of 5, and your interest rate is 10%. So our payment will be $32,759.50. And like I said, we did these in Excel. So if you do the equal PMT parentheses and then plug in these numbers, it'll tell you, that's an easy way to get this answer. Okay, so number 6, now consider the uneven cash flow stream stemming from the lease agreement given in the case. What is the present year zero value of the annual lease cash flows if the opportunity cost rate is 10% annually? And does the office renovation and subsequent lease agreement appear to be a good investment for the company? For 6A, so we did a 10% rate like we had, and did a net cash flow diagram here. So as you can see, our present value or net present value for year zero is $47,328.61. And then for 6C, let's see, it's asking if the office renovation and subsequent lease appear to be a good investment for the company. And so it says, yes, the renovation returns a positive net present value, so it would be a good investment. And then number 7, assume that it's 5 years later and the company is unable to accumulate the $200,000 needed to make this software purchase. Instead, it's forced to borrow the $200,000. So it's a loan and it calls for repayment in equal annual installments over a 4-year period, with the first payment due at the end of the year. Assuming that the company can borrow funds at a 10% rate, what amount of interest and principal will be repaid at the end of each year of the loan? So we're trying to find the interest and principal. So if we look here, we can see this equation that we got from the book. And what is our annual payment going to be? Let's see. Oh, sorry. If we plug it into the equation, and we go here, it looks like the amount of interest is in the 4th column over, and then the principal that will be repaid after 4 years is the $57,358.33. So this was just done in Excel. So I apologize if some of those were confusing, but I hope that this helped, and good luck on this assignment.